In this lesson, we're going to be going through some of the exponent laws that you discussed in depth in grade 9. So before we start, I just wanted to go through some of the basic terminology that you're going to be using. Here you'll see we have an a that is called the coefficient, our b is our base, and the little number in the superscript here is an x, which is our exponent or a power. So if I was going to do an example with you right now and I said 4 times 2 to the x, the 4 would be my coefficient, my 2 would be my base, and my x would be my exponent. The first exponent rule that we're going to be talking about is the multiplication rule. So what we're going to see here is that when we have two terms that have the same base, so an a to the x times an a to the y, we can rewrite that as a to the x plus y. So if I was going to be doing an example with you here, and I said 2 to the 10 times 2 to the 11, that would be 2 to the 21. Now, it doesn't necessarily even have to be with numbers. It could be just with variables. So if I had a to the 3 times an a to the x, it would be a to the 3 plus x. Now, before we move on to the next law, I did just want to quickly mention that if I specifically say solve, then you would have to continue and actually get an answer. If I just say simplify, this is where we would stop. For the purposes in this course and this chapter, you will be just simplifying a large majority of the time until we start getting into word problems where you will be solving, but I will always let you know which I want. The second law we're going to be talking about is the division law. So the division rule or law says that if we have a to the x divided by a to the y, it becomes a to the x minus y. Now, some of you may remember seeing it written as a fraction, and that's basically the exact same thing. So a to the x over a to the y is equal to a to the x minus y. Now, again, we're going to go through a couple examples here. If I just start off and I say that we have a 10 to the 24 divided by a 10 to the 5, we would be doing 10 to the 24 minus 5, so a 19. And again, if I were to be giving you an example with letters, and I said a to the 4 divided by a to the x, it could become a to the 4 minus x. Our third law is the power of a power, or also known as nested powers. So a to the x all to the exponent y is equal to a to the x times y. So jumping into an example, if I had 2 squared cubed, we already know that this means 2 squared times 2 squared times 2 squared, and we already had the rule that said we would, if we're multiplying, we add the exponent. So I would get 2 to the 2 plus 2 plus 2, which is 6. Now, instead of thinking that every single time, I can just realize that I have this power of a power rule where it's going to be 2 to the 2 times 3, which is also 6. If I'm going to do another example and I had a to the 2 to the x, it would be a to the 2x. Law number 4 is the power of a product rule. So when we have a product that is all being brought outside to one exponent, that does need to go through to each of the terms inside of the product. So for example, if I have 2x squared, the exponent 2 needs to be brought into both terms inside. So really I'm going to be getting 2 squared times x squared, so 4x squared. Now, this also works the other way. So if I had x to the n times y to the m all to the p, then I know that I have x to the np times y to the mp. The p needs to be brought into both terms. My power of a fraction rule says that if I have a fraction raised to a power, then the exponent or the power needs to go into both the numerator and the denominator. So a over b to the x does become a to the x over b to the x. So if I'm talking about examples again, if I have 2/3 to the 3, this does become 2 to the 3 over 3 to the 3, which obviously I could expand a little further or simplify a little further, but I'll just stop here for now. And if I had x to the n over y to the m all to the exponent p, this would become x to the np divided by y to the mp. The last quick law that I want to discuss is the zero exponent. So the zero exponent law basically just says that anything to the power of 0 is equal to 1. So no matter how crazy I make this number, anything to the power 0 is just 1. A, b squared c to the power of 0 is 1. Before we get into some longer examples, I did just want to quickly talk to you about some common mistakes that I typically see. So if I'm asking you to evaluate something as easy as 2 to the 3, it does mean 2 times 2 times 2, which is 8. If I asked you to evaluate negative 2 to the 3 is only at the 2 or touching the 2, so this answer would be negative 8. Now if I put a bracket here, this now means that I'm doing negative 2 times negative 2 times negative 2, which would also give me a negative 8. With that in mind, if I had 2 squared, I would get 4, and if I had a negative 2 squared, again, this exponent of 2 is only for the 2, so I would get a negative 4, and if I had a negative 2 in brackets squared, I would get a positive 4, because negative 2 times negative 2 is a positive result. In these examples, I am going to be simplifying and not evaluating. So my first example is going to be 3 squared times 3 to the 4 divided by 3 cubed. Now I see in the top I'm multiplying two terms with the same base, so I will be adding those exponents. So the 2 plus 4 does give me a 6. Now that I'm dividing two terms with the same base, I will be subtracting those exponents. So the 6 minus the 3 to give me a 3. My second example is going to be x squared times x to the 4 divided by x to the 3. I have two terms with a base of x, so I will be adding those exponents. So 2 plus 4 is 6. And then an x to the 6 divided by an x to the 3, I will be subtracting since I am dividing, and I will get an x to the 3. Getting a little bit trickier as I go. 2 to the x to the 5 all cubed times x to the minus 10 divided by 4x squared cubed. So the first thing that I'm going to do is recognize that this cubed does need to go into both of these terms. 2 cubed times x to the 15 times x to the negative 10 all divided by, this cubed is not affecting this 4, so I am just rewriting the 4, and x squared cubed does give me x to the 6. If I'm going to simplify this even more, I am going to get 2 cubed is going to give me 8, and an x to the 15 times an x to the negative 10. I need to be adding those exponents to get an x to the 15 subtract 10, so x to the 5, all divided by 4x to the 6. And in my last step, I have an 8 divided by 4, so a 2. X to the 5 divided by x to the 6, I need to be subtracting those exponents, and I will be getting an x to the negative 1. One last example here, 2 times a cubed times b squared all cubed times 3a to the 4 b to the negative 5 all to the exponent 0 divided by 2ab to the 6. Now what I first see is that I do have this entire bracket being raised to the power of 0. Now I know because of my 0 rule, anything raised to the power of 0 is just 1. So we are basically going to be multiplying by 1 or ignoring that. The next thing that I'm going to see is that I have something in brackets being cubed, so that cubed needs to be distributed through every term in this first bracket. So I will have 2 cubed, a to the 3 times 3, so a to the 9, and b to the 2 times 3, so b to the 6. The exact same thing's going to happen to the bottom, so the 6 is going to be multiplied or distributed through to each of these terms. So 2 to the 6, a to the 6, b to the 6. At this step, it would be a common mistake to simplify the 2 cubed and the 2 to the 6. I do not need to do that since these are the exact same base. I can just subtract the exponents like I would for my variables. So I am going to be doing 2 to the 3 subtract 6, so a negative 3, and a to the 9 subtract 6, so a positive 3, and b to the 6 and divided by b to the 6 is just 1, or I don't need to write it again.